Welcome to a part 6 of AWS Solution Architect Associate full crash course. In this part, we're going to cover high availability. Are you prepared for failure in your AWS architecture? Dr. Werner Vogels, VP and CTO of AWS, famously said, "Everything fails all of the time." This mindset is crucial when designing for failure in the cloud. Let's explore how to improve your AWS architecture to prevent failure. To start, it's essential to grasp the AWS global architecture, focusing on availability zones and regions. Availability zones are the physical data centers of AWS, while a region is a collection of availability zones geographically located close to one another. By deploying resources across different geographical locations, you can add high availability into your design. Let's revisit a basic design scenario and see how we can enhance it. By utilizing multiple availability zones and deploying additional resources such as an application load balancer and a standby RDS instance, you can add high availability into your design in your case of a failure. In the event of a disaster, having the foresight to implement a solution that recovers from a major outage ensures you remain operational and continue to serve your customers. This is high-level example of design for failure. When it comes to architecture for design for failure at the global architecture level, you need to determine the business impact of when your solution becomes unavailable. It's a case of weighing up the cost benefit risk of your deployment design. Designing for failure is AWS is about being prepared for the unexpected. Now let's dive into the world of disaster recovery and understanding the crucial concepts of recovery time objective and recovery point objective. Disaster recovery is all about restoring operations quickly with minimal data loss. RTO is the maximum time a service can remain unavailable before it damages the business, while RPO measures the acceptable data loss between the last backup and the service interruption. To meet RTO and RPO needs, there are different recovery strategies to consider when architecting in AWS for your DR plan. These includes backup and restore, Pilotlight, warm standby, and multi-site active, each with varying RTO and RPO metrics. Understanding RTO and RPO is essential for building an effective disaster recovery strategy. By implementing the right recovery strategies, you can minimize business impact and data loss, ensuring a stable operational state in the event of disaster. If you're struggling to determine the correct RTO and RPO of your cloud architecture and applications, so let's have some guidance to help you navigate these essential aspects of disaster recovery and business activity planning. It's crucial to access each application individually, as their RTO and RPO requirements will vary. Lower metrics may necessitate more complex architecture and higher cost, so understanding these needs is key. Ask yourself and your team important questions such as impact of application loss, associated cost, service level agreements, dependencies, and regulatory requirements. These answers will help classify RTO in seconds, minutes, hours, or days. Similarly, consider data recreation backup strategies and the rate of data change when determining RPO. These factors will guide your backup strategy and data recovery process. So remember, there's a one size fits all approach to RTO and RPO. It's all about evaluating your internal business factors before designing and implementing your disaster recovery strategy. So if you're curious about the architecture behind the recovery strategy of backup and restore, so let's dive in and explore the key elements of this approach. The backup and restore method provides the longest recovery time objective and recovery point objective values. It's crucial for deployments that don't pose a significant business risk if services are not quickly restored. AWS offers various services for point-in-time recovery, including RDS Snapshot, Amazon Aurora DB Snapshot, Dynamo DB Backup, and more. These services provide flexibility and reliability for your recovery strategy. AWS Backup is a versatile AWS managed service that centralizes backup management across multiple regions. It offers fully auditable compliance controls and consolidated logging for your all backups. By implementing a simple architecture using core AWS managed services, you can effectively manage your RTOs and RPOs. Keep in mind that the complexity of your resources and the volume of data can significantly impact your recovery time. Understanding the architecture behind backup and restore strategy is essential for ensuring the resilience of your deployments. So explore the possibilities and optimize your recovery approach with AWS services. So are you familiar with the Pilotlight recovery strategy? So let's dive into how these approach can help reduce your recovery time and ensure your data is readily available in the event of a disaster. The Pilotlight method introduces data replication between primary and disaster recovery regions, reducing your recovery point objective and allowing for faster resilience scaling, resource scaling. With continuous asynchronous data replication, AWS services like Amazon S3, RDS, Aurora, DynamoDB, DocumentDB, and Elastic-Cache ensure minimal replication latency, significantly reducing RPO in the event of disaster. Imagine a three-tiered web application deployment with the primary region serving customers through a web application accessed via Route 53. The minimal infrastructure in the disaster recovery region includes the VPC, ELB, autoscaling groups, and an Aurora replica, all managed using infrastructure as a code tool like CloudFormation. In the event of a disaster, the secondary ELB can be activated. Application servers provisioned using pre-configured AMIs and the Aurora replica promoted to the primary data store, ensuring a shift recovery. So the Pilotlight recovery strategy offers reduced RPO and minimal infrastructure in the disaster recovery region. Ensure your data is readily available when you need it in the most. If you are looking to minimize your RTO and RPO greater than what backup and restore or Pilotlight strategies could offer when planning for a regional failure, then warm standby is your next best choice. Warm Standby effectively builds upon Pilotlight, offering a scaled down version of your primary region up and running in your designated DR region. This reduces your RTO more than what Pilotlight could offer. The increased cost is due to the additional resources running, but there aren't any other distinguishing features between the two strategies. In the event of a regional failure, the warm standby offering allows your web servers to immediately start processing requests, reducing your RTO. However, you will need to rely on your auto scaling groups to effectively scale out your infrastructure as your workload increases. So by implementing the warm standby strategy, you can ensure a reduced RTO and RPO in the event of a regional failure. Introducing the multi-site active-active recovery strategy. The multi-site active-active recovery strategy offers the lowest recovery time objective and recovery point objective for critical applications and solutions. By deploying infrastructure across multiple regions at full scale, there is no need for failover events to be triggered, ensuring the continuous access to your applications and data. In this configuration, both regions are actively running operational overheads. Route 53 routes traffics based on specific policies. The ELB balances incoming request and DynamoDB global tables handles data replication and continuous backups in both regions. While this strategy offers robust continuity testing the ability of the remaining regions to handle additional traffic and potential data and corruption or deletion are more important considerations. Restoring databases from backup may also affect the RTO. The multi-site active recovery strategy provides unparalleled resilience for critical applications, ensuring seamless access to services and data in the event of the disaster. Are you confused about the difference between high availability and fault tolerance in IT systems? Let's break it down. High availability focuses on maintaining a percentage of uptime to ensure operational performance. often aligned with an SLA. For example, using multiple availability zones and EC2 instances with an elastic load balancer can contribute to a highly available solution. Fault tolerance goes beyond high availability, offering greater protection against component failures. These can involve deploying the system across multiple regions to maintain operation even in the event of an entire region failure. In summary, fault tolerant systems are inherently high available, but not all high available solutions are completely fault tolerance. The choice between high availability and fault tolerance depends on the business impact of potential failures. So remember, it's not if a failure occurs, but when. Now let's do an overview of AWS storage gateway options. So let's explore the different configurations available and when to use them. So file gateways allow you to securely store files as objects within S3, providing a type of file share that can be mounted on mapped drives to an S3 bucket as if it is were held locally on your corporate network. This option is ideal for optimizing latency and reducing egress traffic costs. Now let's discuss some volume gateways. Stored volume gateways are often used to back up local storage volumes to Amazon S3 while ensuring the entire data library remains locally on premises for low latency data access. On the other hand, cached volume gateways utilize Amazon S3 as the primary data storage, with local data storage acting as a buffer. This option is perfect for maintaining low latency with recently accessed data. Lastly, the tape gateway, known as a gateway VTL, allows you to back up data to S3 and leverage Amazon Glacier for data archiving. This cloud-based tape backup solution replaces physical components with virtual ones, providing a robust and secure backup and archiving solution. With these options, AWS Storage Gateway offers versatile configurations to meet your storage needs. Now let's dive into the world of multi-AZ in Amazon RDS. It's a feature designed to ensure resiliency and business continuity for your RDS instance. Multi-AZ stands for Multi-Availability Zone. When configured, a secondary RDS instance known as a replica is deployed within a different availability zone within the same region as the primary instance. This provides a failover option for the primary RDS instance. In the event of an outage, the failover process is automatic and managed by AWS. It typically takes between 60 to 120 seconds depending on the database size and activity. You can configure RDS to notify when a failover event occurs. For SQL Server, multi-availability zone is achieved through SQL Server mirroring, which provisions a secondary instance in a separate AZ for resilience and fault tolerance. Amazon Aurora clusters are fault tolerant by default, but enabling multi-AZ can significantly reduce the time it takes to provision a replica in the event of a primary instance failure. So that's a wrap on multi-AZ in Amazon RDS. Stay tuned for the next segment on RDS read replicas. Now let's explore how read replicas can enhance the performance and resiliency of your database. Read replicas are separate instances that provide read-only access to your database data. They help offload read-intensive traffic from the primary instance, improving overall performance. By deploying read replicas, you can scale your read performance to a wider range of tools and applications. Additionally, you can enhance your disaster recovery capabilities by deploying read replicas in different regions. MySQL, MariaDB, PostgreSQL database engines, read replicas have significant prerequisites and limitations. For example, MySQL read replicas are only supported for databases running MySQL 5.6 or later. It's crucial to monitor the synchronization of RAID replicas with their source database using Amazon CloudWatch. These ensures optimal performance. In conclusion, RAID replicas play a vital role in improving database performance and resiliency. Now let's dive into Amazon Aurora's HA configuration options. Let's explore the key features and benefits that ensures maximum uptime for your applications. Amazon Aurora separates the compute layer from the storage layer, allowing you to adjust data availability. The storage layer is shared among all compute nodes, providing highly redundant and durable data. Aurora uses a quorum and gossip protocol for consistent data and offers automatic failover, ensuring quick recovery in case of a master failure. There are four types of connection endpoints, each serving different purposes. The reader endpoint is ideal for read-intensive workloads, while custom endpoints offers flexibility for specific tasks. Understanding these HA configurations option empowers you to make informed decisions on your Amazon Aurora setup, ensuring robust and reliable performance for your applications. Let's dive into some Aurora's powerful configuration options. Aurora can be configured with a single read write master instance and up to 15 read replicas. Replication of data is confirmed asynchronously in milliseconds, providing the impression of synchronous replication. Read replicas allows for increased read throughput and offload database reads from the master instance. In the event of the master instance going down, any read replica can be prompted to take over the role of being master. Daily backups are automatically performed by with a default retention period of 1 day, and a manual snapshots can be taken at any time. Restores are performed into a new database, providing flexibility and security. So introducing Aurora Serverless, the elastic auto-scaling database solution that adopts your application's demands and saves you money by only billing when in use. Aurora Serverless eliminates the need to plan and allocate instance sizes. Instead, you set lower and upper limits of capacity measured in Aurora capacity units. These service continuously adjust and optimizes capacity based on incoming demand, automatically starting and stopping compute instances in seconds. Underpinned by a fault tolerance, self-healing storage layer, Aurora Serverless ensures high availability without the need for manual configuration. It auto-adjusts the compute layer and capacity behind the scenes, scaling up or down as needed. When traffic drops off, it can even shut down the compute entirely, saving you cost on unused capacity. With a single connection endpoint, Aurora Serverless simplifies database access. It also offers the Web Service Data API feature, enabling HTTP web server interface for executing queries without the need for a JDBC driver or connection. This feature is particularly useful for implementing Lambda functions and can be accessed through the AWS CLI. Aurora Serverless performs continuous automatic backups with a default retention period of 1 day, extendable up to 35 days. These backup style allows for restoring to a point in time with the retention period, providing peace of mind for data recovery. Now let's dive into the high availability configuration option available with DynamoDB. By configuring these options, you can maximize the uptime of your dependent applications. DynamoDB automatically partitions data and incoming traffic across multiple partitions stored on backend servers distributed across three different availability zones within a single region. This default setup provides a strong starting point for availability. You can dial up or down the provisioned throughput of the DynamoDB database to ensure it meets the needs of your application as it grows. These results in additional partitions and replications, all happening automatically in the background. Global tables, the latest implementation of cross-region replication, evaluate the availability of your data and enable applications to take advantage of data locality. This feature allows a single table to be replicated across one or multiple alternate regions, protecting your table from regional outages. With DynamoDB's high availability configuration options, you can ensure the high availability of your data and applications. So let's stay tuned and learn more about how to implement these options and maximize the uptime of your DynamoDB dependent applications. If you are looking for a way to request a full backup of a table at a specific moment in time, look no further than on-demand backups. On-demand backups are manually requested and can be performed through the AWS Dynamo DB console or by using the AWS CLI. They are useful for scenarios like table corruption, regulatory data requirements, and testing. Scheduling on-demand backups provides the ability to restore table data back to a point in time. They can be requested anytime with no limit to the number or retention period. Plus, backups are completed within seconds and have zero impact on table performance and availability. In the AWS Dynamo DB console, we can easily view and restore backups. Once restored, the table contains all the items captured at the time the backup was created. So on-demand backups provide peace of mind and flexibility, ensuring your table data is secure and easily restorable. Now let's learn about point-in-time recovery, PITR. So PITR is an enhanced version of the on-demand backup and restore feature, providing the ability to perform point-in-time recoveries. It's a safety net for data modifications, allowing users to restore back to a specific time, eliminating the need to plan backup schedules. So PITR operates at the table level, enabling recovery for any time between the current time and the last 35 days. Once enabled, users can request a recovery by specifying a date and time with second precision, restoring the data into a new table in the same region or a different region altogether.